Under Geneva's cloak, inside the Hadron Collider, a human shock lies on the Earth's surface. Creativity and a typical indicator of intelligence will destroy the beast. The Hadron Collider is a smart evaluation guide, permitting analysts to examine the subatomic realm in general, causing the revelation of the perplexing God particle, a Higgs boson, back at the moment when Brian Cox, a prominent physicist, made a chilling statement. In the past, he made a statement that sent waves of marvel through the philosophical realm. CERN's research has been the subject of something that could have broadened ways far beyond our comprehension. Our primary goal was for educational purposes, yet we were led down a path that could lead to disaster, requiring us to plunge into the pit of this clear problem sooner rather than later. Before we begin the assertion, let's investigate what atom accelerators are and how the Large Hadron Collider, LHC, functions. Operated by CERN, the LHC is a 17-mile ring of superconducting magnets, one of the most important and, for the most part, the most solid particle smashes in human scientific achievement. The truth of the situation is that its power is so immense that it can surpass the actual circumstances of the universe's creation. But should this construction serve as an opening for the analysis of the universe from within? Keep an eye out, for there is something even more alarming. CERN, founded in 1954, is one of the most significant and prestigious research establishments. It has 23 member states and a large gathering of specialists. It is the center for the LHC's development and cooperation, CERN's focal endeavor. However, it is only one part of a vast network of fuel spikes and pedals, not made for horses or engines, but for subatomic particles competing for existence. The LHC accelerates protons, sending them nearly at the speed of light on a misshapen course that reflects the energy of the universe at the moment of the Big Bang. The resulting temperatures are 1 million times hotter than the Sun's core. A vast array of protons is guided by magnets while experiencing amazing cooling systems that protect them at temperatures even lower than space itself. The LHC consists of 1,232 dipole magnets, which steer the protons, and 392 quadrupole magnets, which focus the beams just before impact. Another well-known type of magnet is used to press the particles together, maximizing impact possibilities. CERN's mission is to smash particles with the precision of securing two needles 6 miles apart, ensuring they meet at the exact point of impact. The amount of precision required is staggering, and the LHC's arrangement is an engineering marvel. Hidden 574 feet underground, far from the system as a whole, radiation fields are cooled to a temperature of -456 degrees Fahrenheit, colder than the vacuum of space itself. This chilling environment is necessary for the use of superconducting magnets. The LHC support centers are designed to crash particles at 4 locations across the accelerator ring, corresponding to 4 major detectors: ATLAS, CMS, ALICE, and LHCb. Each of these detectors has a distinct purpose in investigating different aspects of particle science. They house massive cameras that capture particle collisions, and specialists analyze the data, searching for signs of the elusive Higgs boson, proposed as the God particle, a fundamental component of the universe's structure. Analyzing these collisions is comparable to looking at an unending jigsaw puzzle, where the pieces are dark and the image is difficult to comprehend. By focusing on this microcosm, we gain insights into the universe. However, with each revelation comes a new question, and with each discovery, a new challenge. The LHC is more than just a technical instrument. It demonstrates human ambition, innovation, and progress. It embodies our never-ending search for knowledge and our eagerness to comprehend the fundamental forces that shape our universe. Yet, as we push the boundaries of what we know, we must also consider the ethical dilemmas and existential questions that arise. What are the dangers of examining the unknown? Should our pursuit of knowledge unexpectedly unleash forces beyond our control? In the prestigious halls of CERN, where the limits of human understanding are constantly tested, a recent disclosure has sent chills down the spines of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a significant figure in the field of particle physics, recently made a statement that has left the scientific community both intrigued and concerned. An echo of Cox's words filled the room, presenting an unsettling possibility. The goal of CERN's massive hadron collider is to create a miniature version of the Big Bang, a replication of the actual event that gave rise to our universe. The physicist also acknowledged the potential consequences of this objective, bringing attention to the LHC's remarkable ability to unlock the secrets of the Higgs boson and investigate the mystery surrounding dark matter, a substance that is a significant component of the universe. Imagine having the ability to discover the universe's true essence. It's an exciting opportunity, but one filled with dangers. The very idea of the Big Bang is a theoretical construct, and the LHC's pressures, temperatures, and energies resemble those at the dawn of the universe. It's as if we are witnessing the beginning of existence itself. Despite possessing such power, we must confront profound responsibilities, along with the constant questions of limits and risks. Consider what happened to Russian physicist Anatoly Bugorsky when he Bugorsky, a researcher at the Institute for High-Energy Physics in Russia, was working on the U-70 synchrotron in 1978 when he accidentally exposed his head to a beam of accelerated protons. The beam, traveling at nearly the speed of light, passed through his skull, entering the back of his head and exiting near his nose. He reported seeing a flash brighter than 1,000 suns, but felt no pain. However, over the next few days, severe swelling and burns developed, and parts of his skin began to peel away due to radiation exposure. Scientists at the time believed he would not survive, as the dose he received, 200,000 rads, was far beyond lethal levels. Miraculously, Bugorsky survived, but the incident left lasting effects. One side of his face became paralyzed, and he suffered from seizures later in life. This event remains one of the most extreme examples of human exposure to a particle accelerator's power. Now, consider the LHC, an accelerator far more powerful than the one that struck Bugorsky. If a single proton beam could cause such devastating effects on a human body, what might happen if the unthinkable occurred, if a collision at CERN resulted in something beyond our understanding? The concerns, tearing the fabric of reality? The LHC's experiments push the boundaries of what we know about physics. But some theorists speculate about unintended consequences. Could the LHC create microscopic black holes? Could it trigger vacuum decay, an event that destabilizes space itself? Could it open a rift into another dimension? These fears, while often dismissed by mainstream physicists, have been discussed in theoretical physics. The creation of mini black holes is, in fact, one of the possibilities predicted by some interpretations of string theory. CERN itself has acknowledged this potential but argues that such black holes would evaporate instantly due to Hawking radiation. Similarly, the idea of vacuum decay stems from the notion that the Higgs field, the energy field associated with the Higgs boson, could theoretically exist in a false vacuum state. If disturbed, some theorists argue, it could trigger a catastrophic event where reality as we know it collapses. This is an extreme scenario, but the fact that it is even theoretically possible raises questions about our pursuit of knowledge. Brian Cox's warning, a chilling revelation. In a recent statement, Brian Cox discussed the philosophical and scientific implications of the LHC's work. He acknowledged that humanity is on the edge of understanding something truly fundamental about the universe, but he also hinted at something more alarming. There are forces at play, Cox said, that we do not yet fully comprehend. The pursuit of knowledge is noble, but we must also be cautious. The LHC allows us to peer into the fundamental structure of reality, but what if reality does not like being observed? His statement was met with a mix of intrigue and concern. Some dismissed it as philosophical speculation, while others saw it as a veiled warning. The ethical dilemma: should we continue? CERN's mission is to expand human knowledge, but at what cost? The more we probe the mysteries of existence, the more we risk unintended consequences. Science has always been about pushing boundaries, yet history has shown that unchecked curiosity can lead to disaster. As the LHC continues to operate and future accelerators, even more powerful, are proposed, humanity faces a profound question. Should we keep going? If the answers we seek lie beyond the veil of reality, should we dare to tear it apart just to see what's on the other side? In 1978, Bugorsky was working at the U.S. high-energy synchrotron at the Institute of Russia's Energy Physics when an incident nearly ended his life. A beam of protons accidentally entered his head. Despite the severe tissue damage, he remained alert and was able to walk for treatment. His experience, while disturbing, serves as a cautionary example of the tremendous power and threat posed by particle accelerators. The dangers of a particle accelerator, such as the LHC, should not be underestimated. The potential for real, extraordinary reactions in these structures is not science fiction. Concerns have been voiced by some in the academic community, particularly regarding the possibility of creating tiny black holes. Black holes are regions of space where gravity is so powerful that even light cannot escape. Some scientists fear that the LHC might create a black hole, albeit on a tiny scale. If such a black hole were to form, it could theoretically consume Earth from the inside. However, scientists at CERN have assured the public that any black holes created would quickly disappear, posing no threat to our planet. Despite these assurances, the possibility has sparked conversations, phobias, and a heightened awareness of the power we are dealing with. The operation of the LHC is crucial to understanding its potential to create a black hole. When protons are smashed together at nearly the speed of light, the energy involved alters the structure of spacetime itself, like watching a trampoline bend and stretch. These distortions in spacetime prompt the question, what could occur if they result in the formation of a void? In the realm of quantum physics, where the fundamental rules of the universe are strange and mind-boggling, some theories suggest that additional, significant unidentified factors might be concealed within the fabric of space. If these elements exist, the LHC might tap into them, possibly creating a gravitational anomaly that leads to the formation of a black hole. This dreadful possibility has caught the attention of some prominent researchers, including Stephen Hawking. In his book, Hawking warned of a situation in which the Higgs boson might behave unpredictably at very high energy levels. This anomaly could, in theory, cause a catastrophic event known as vacuum decay, which might not only destroy the Earth but unravel the universe itself. Sir Martin Rees, an English astronomer and astrophysicist, also acknowledged the potential dangers of particle accelerator experiments. In his book on the future of humanity, he suggested that CERN-based experiments might lead to catastrophe if they trigger an uncertainty in the vacuum, a hypothetical event that could result in a significant change in the very structure of spacetime. He warned that, despite the low risks, the repercussions of such an incident would be catastrophic, with the potential to alter the entire universe. CERN scientists have fully acknowledged the possible risks associated with their experiments. They have implemented numerous safety protocols and measures to mitigate any potential threats. However, scientific research inherently involves some degree of uncertainty, especially when venturing into uncharted territory. The pursuit of knowledge has always carried a certain level of risk. Nevertheless, it is this very willingness to push boundaries that has propelled humanity forward. The LHC represents the culmination of many decades of scientific progress, embodying our insatiable curiosity about the universe. However, the risks posed by LHC experiments cannot be ignored. While the likelihood of catastrophic events may be low, the potential consequences are profound. This is why it is so important for experts, policymakers, and the public to engage in candid discussions regarding the ethical and existential implications of these studies. The CERN Hadron Collider is a marvel of human ingenuity and scientific achievement, providing incredible insights into the fundamental nature of the universe. Yet, with immense power comes immense responsibility. It is absolutely necessary that we approach this groundbreaking research with caution. As we continue to unlock the universe's secrets, we must remain conscious of the potential dangers, ensuring that our quest for knowledge does not come at the expense of our safety or the well-being of our world. CERN stands as a testament to humanity's relentless pursuit of understanding, but behind its impressive exterior lies a domain of profound scientific inquiry, full of potential outcomes and ethical considerations. As we push the boundaries of physics with the Large Hadron Collider, LHC, and similar experiments, we must acknowledge the dual nature of scientific advancement. It offers both incredible promise and potential peril. The discoveries made at CERN could revolutionize our understanding of the universe, from the nature of dark matter to the possibility of extra dimensions. However, the very act of exploring these frontiers carries inherent uncertainties. One of the most exciting yet controversial theories suggests that the LHC might uncover hidden dimensions beyond our conventional understanding of space and time. Some physicists propose that the fundamental forces of nature, such as gravity, may extend into unseen dimensions, influencing our observable universe in ways we have yet to comprehend. If true, this would fundamentally reshape our understanding of reality and open doors to new technologies, possibly even interdimensional travel. However, concerns remain about the unintended consequences of manipulating such extreme energy levels. While the scientific consensus holds that the LHC is safe, history has shown that paradigm-shifting discoveries often come with unforeseen risks. Some theorists speculate that certain high-energy collisions could produce exotic particles that, while harmless in theory, might interact with matter in unpredictable ways. Could these experiments inadvertently alter spacetime? Could they introduce new physics phenomena beyond our control? Despite these concerns, most experts argue that the LHC's safety measures, along with the laws of physics as we currently understand them, prevent catastrophic scenarios. Even in the unlikely event of a micro-black hole forming, it would evaporate almost instantly due to Hawking radiation. The same laws of physics that allow us to predict the behavior of atoms, galaxies, and the expansion of the universe also suggest that the risks associated with LHC experiments are negligible. Yet, the ethical implications of high-energy physics research persist. How do we balance scientific curiosity with existential risk? Who holds the responsibility for ensuring that our experiments do not pose unforeseen dangers to humanity? These questions go beyond particle physics and extend into the broader realm of scientific ethics. Throughout history, humanity has faced similar dilemmas. When nuclear physics advanced to the point of creating atomic weapons, society had to grapple with the consequences of wielding such power. The discovery of genetic engineering has raised moral questions about the manipulation of life itself. Now, as we delve into the most fundamental aspects of the universe, we find ourselves once again at a crossroads. Do we proceed with bold curiosity, or do we pause to consider the full scope of what we might unleash? In the end, science is a tool, a means of uncovering truth. It is neither inherently good nor evil, but rather shaped by the intentions and caution of those who wield it. The LHC stands as one of the greatest scientific endeavors in history, a beacon of human ingenuity and determination. But as we continue our journey to unlock the secrets of the cosmos, we must do so with both ambition and wisdom. Perhaps the most important lesson of all is that knowledge, like the universe itself, is vast and unpredictable. While the risks may be minimal, the discussions surrounding them are necessary. As long as we approach scientific discovery with responsibility and foresight, we can ensure that our pursuit of the unknown remains a force for progress rather than peril.